Today we're going to talk about electron configurations. Electron configurations are quite difficult to understand, and so I have come up with this analogy that makes it somewhat easier to understand. And to come up with this analogy, first we must start out with a river and a hilltop. In this small town that we're going to plant or build on this side of the hill, there's going to be 8 streets. On these 8 streets there are going to be 4 different types of houses. The first type of house is an S house. An S house is a relatively small house. It is only one room, and each room will hold 2 people, and in our analogy we'll learn that it holds 2 electrons. The second street is slightly longer and has the ability to hold 3 rooms, and we call these a P house. Notice that I'm making these with lower cases and not upper cases. The third street is just a little bit longer, and it has a D house on it. D houses have 5 rooms, and so it has room for 10 people. Remember that P houses have room for 6 people, and S houses have room for 2 people. The third street, the 4th street, the 5th street, and the 6th street have room for B houses. Later, when we talk about how this applies to the atom, we'll show that this actually goes on to infinity, but for the purposes of the periodic table that we use daily in chemistry, all of the atoms in their ground state will fall into these different locations. The next housing development are called F houses, and they hold 14 different people, and so they're going to have 7 different rooms. And so we have our town completed. The order in which these electrons or people start to live in the houses, they want to live closest to the river, so the first house that is going to fill is the first house on the first street, followed in this order. And so now we have a model of our housing development, or an analogy for the way in which electrons fill the shells in an atom. If we're going to write a letter to any electron in this particular housing development, we will have to address the letter. For example, what if we were going to write an electron or a letter to the electron in hydrogen? Hydrogen has 1 electron, and so we start out by writing down what street it lives on, which is the first street, what house it lives in. Notice that I write that with a lowercase s. and there is one electron in that house. So the address on the letter would read 1s1. If we are going to write an address to helium's electrons, there are two of them. We would start out by writing down the street number, followed by the house, and finally how many people live in that house. So 1s2 is the electron configuration for helium. If we go to a little bit more difficult one, let's say carbon. Carbon has 6 electrons. So the first 2 electrons are going to live on the first street in an S house, and there's going to be 2 of them. So that's taken into account 2 of the 6 electrons. The next 2 electrons are going to live on the second street, also in an S house, and there's going to be 2 of them. That gives us, we count the superscripts, so 2 plus 2 is 4. We still need 6 more electrons, or excuse me, we need 2 more electrons to make our 6, and so they're going to live on the second street in a P house, and there are going to be 2 of them. So that is a simple way of looking at that. Alright, now let's do a little bit more difficult element. How about neon? Neon has 10 electrons. The first 2 electrons are going to be in 1s2. The second 2 electrons are going to be 2s2. The third house that fills is going to be on the second street. It's a P house. So it's a second street, P, and there's going to be 6 electrons that live there. 6 plus 2 is 8, plus 2 is 10. There's 10 electrons. So that is the complete electron configuration for neon. Let's try something like silicon. Silicon has 14 electrons. The first 2 electrons are going to live on the first street, and there's going to be in an S house, and there's going to be 2 of them. The next 2 are going to live on the second street in an S house, and there's going to be 2 of them. Notice that they follow the same pattern, time after time after time. And the next house that fills is a 2P, and again there's 6 of them, so we've got a total of 10. The next one that fills is on the third street. It's an S house, and there's 2 of them, so we've got 6 plus 2 is 8, plus 2 is 10, plus 2 is 12. We need 14, so we need 2 more. So we look up here and we see that the next house after the 3S house is the 3P house. And it's not going to be full because we only need 2 more electrons, so it's going to be 3P2. And that's the electron configuration for silicon. How about something really difficult like zinc? With 30. Zinc has 30 electrons, so we got 1s2, 2s2, 2p6, 3s2, 3p, and remember that the p house will hold 6. And so now the 3p house, we go back to the 4s2. After the 4s2 fills, then the 3d fills. So we've we've got 10, 18, let's start it over, confused myself. We've got 10, 18, and 2 is 20, 26, 28, 30. So that's the electron configuration for zinc.